Welcome, I'm here at Electronica 2010 and I'm here with Robert Kelman, Microcontroller Marketing Manager from the Industrial Business Group at Renesas.
Hi.
Renesas just announced a new product today here at Electronica. Perhaps you can give us some more information on that.
Absolutely. We announced today our newest version of the SuperH family.
Okay.
It's the SH7239. It's a SuperH device based on the SH2A core, running at 160 megahertz, so very high performance device, aimed at the digital signal processing market for inverter control, so motor control for industrial drives, and also for the solar inverter market.
Okay. And what are the key features and the unique benefits that designers can have by using those products?
Okay. So there's a couple of features that you'll need on a device to actually access this market to start with, and that's in terms of motor control or inverter timers and analog to digital converters. These are all included on the device as standard to drive three-phase PWM timers. The other things that make this device very unique and very different in the market is that this is a truly microcontroller device. This means that it's a very simple device to program, a very simple device to understand in comparison to the other devices which are in this market, which are often based on a digital signal processing, a DSP architecture, which are sometimes a little bit more difficult to get to grip with in terms of working and programming in C. This is a dedicated microcontroller, so it's been optimized for working in C. This microcontroller has the industry's fastest embedded flash on board. So the device runs at 160 megahertz, running directly from the flash with single cycle access to the flash.
Okay.
What we've seen in this market in the past is that many of our customers are working with different architectures, where they have to load their code from an external flash or from their internal flash into RAM in order to achieve that kind of performance. With the SuperH architecture and its Monas flash, you don't have to do that at all. You can run directly from the internal flash as fast as you could run from your internal RAM, which saves the customer an enormous amount of overhead in terms of startup and also in terms of the cost of the actual BOM, because you do not have to include any additional external memory devices. Not only is the flash really fast, but actually the core is very fast as well. It's one of the fastest embedded microcontroller cores in the market today. It's a superscalar architecture. This means that you can actually execute two instructions at the same time. So with 160 megahertz, we're actually achieving 320 dry stone MIPS of performance, which is almost unheard of in the microcontroller market today. For digital signal processing applications, we also have a floating point unit included in the flash microcontroller, which is very unique in the market. So we have not just a very fast core with fast peripherals and a fast flash, but we also have the floating point unit included as well. And finally, one of the last important things for this kind of market is really the speed at which you can respond to an interrupt. The speed at which you can jump from your standard application code to service an interrupt inside your microcontroller. And the SH has got industry benchmark performance in terms of its response time to interrupts. So in just 6 clock cycles, you can actually jump from your standard code into your interrupt subroutine, which is really very fast compared to what we've seen in the market as well. This is achieved through up to 15 banks of registers in the actual controller core itself. So the interrupt response time is really benchmark. So fast flash, which is unique and only available from Renesas, a very fast core with superscalar architecture and fast interrupt time, all combined together to make this a very competitive solution and a very fast solution in the market, with of course all the standard features that you have to have, such as the timers and the analog to digital converters.
Okay, then thank you very much.
Thank you very much for your time.